Okay, hey Daniel. Alright, you had the question about how to use Ka and maybe concentrations to find pH. So this example is given on page 671. If you want to review it, I'll just walk you through the steps briefly, and then I'll go over another example which might be on a different video. So to start out, if I look at this example problem on page 671, it says calculate the pH of a 0.20 molar solution of HCN. It also tells you to look at Appendix D for the value of Ka. So for some of these problems, you might have to actually look up the Ka, and it does give you the concentration. You are going to be doing an ice table for these problems as well. So the first thing we need to do is go ahead and write out the equations. So we have HCN. So we know we have an acid here. It's dissolved in water. And it's going to dissolve into hydronium ions and CN ions. We know that the Ka for this is going to be Cn times H plus, the concentrations, over HCN. And we also know, if we look back in the appendix, that the Ka is 4.9 times 10 to the negative 10. Alright, so next we're going to plug everything into an ice table using this equation. So we have HCN, H plus, and Cn minus. So I know initially I have concentration of 0.20 moles per liter, and 0 and 0. I know this is going to change by negative x at some point, and these are going to increase by x and x. And so my overall concentrations at equilibrium are going to be 0.20 minus x, and then we'll have x and x. Okay. So now what we need to do is figure out, in order to get to the pH, we need to solve for the concentration of H plus, right? And then we can solve for our pH. So all we need to do is solve for x in this case. So if we solve for x, we're going to plug everything into Ka equation. So we're going to have x squared, right, on top, over 0.2 minus x. Now this is a weak acid, and so because it's a weak acid, we're going to assume that it's dissociating by very little relative to its overall concentration of the acid. And so what we can actually do here is just assume that this is negligible and ignore it. And so we can actually say, we're making a big assumption here, but this has become standard practice because weak acids don't dissolve very much. We can just say that we have x squared over 2. Now we can easily solve for x, because we know that the Ka is equal to 4.9 times 10 to the negative 10. So we're going to multiply both sides by 0.2. And then we're going to take the square root of both sides as well. So if I go 4.9 times 10 to the negative 10 times 0.2, I get 9.8 times 10 to the negative 11, and that's what x squared is equal to. So let's go ahead and take the square root of both sides. And I get, for the concentration for x, and which is also the concentration of hydrogen ions, I get 9.9 times 10 to the negative 6. Now what I need to do in order to find the pH is take negative log of 9.9 times 10 to the negative 6, because that's what pH is. And I'm going to end up with a pH of 5.00. Okay, hopefully that helps, and I will try to put another video up of a problem like this as well. Thanks for your question.